Welcome to Theory of Computation class. In today's class, I am going to give an explanation for computational functions by applying Turing machine. The definition of Turing machine contains the following terms. That means Turing machine, it is a mathematical model which is used to define a language, and also it is used to compute few integer functions in it. So for defining a language, we already discussed the conversion of context-free language to Turing machine in previous videos. So in today, we should able to find the basic technique for implementing computational functions by using Turing machine. So the input for computation function should be in a binary format. So that is the main logic for implementing this concept. So for basic calculations of addition, subtraction and multiplication, the input tape symbol contains only the binary values. So suppose for example, x is equal to 3 means we should store only 3 zeros as input in an input tape. So the number of x values should be saved as number of zeros, and the number of y value should also be stored as number of zeros. For differentiating x number of values and y number of values, the intermediate value should be stored as 1. So here in an input tape symbol, the 1 is represented for splitting x number of zeros and y number of zeros. So this is the main logic behind the construction of addition, subtraction and multiplication process by using Turing machine. So it's not only possible to use this computational function, we can also able to use 1s and 2s complement, and we can able to compare the maximum or minimum of two numbers, square of a number, GCD of a number, or a binary equivalent of an integer by using the Turing machine. So I give few examples for the basic mathematical operations of Turing machine in these videos. So here the addition operation means f of x plus y. So you can, if a function is specified with the plus operation means the basic addition, the meaning is we should sum up the x number of value and y number of value, and the tape symbol should contain the sum of x and y numbers, y values in a zero format. And subtraction is also possible, but only condition means if you use subtraction like f of x comma y, and we are doing x minus y means the x value should be greater than y. Then only the Turing machine can able to do it. If x is less than y, it should return only 0 as an answer. That means it is called as proper subtraction. So I only give the proper subtraction model for the basic subtraction notations. So here compute the Turing machine for the function f of x equal to x plus 1. So for example, I am taking x is equal to 4. So x is an integer value and the integer value 4 is represented. I want the answer as 4 plus 1. If you substitute x as 4, 4 plus 1 is 5. So I already told that the tape contains only number of zeros. So initially all the tape symbols should be stored with blank space. Then if x value is available, you just check the x value. For example, I am taking x as 4, which means that x number of zeros should be stored in a tape. That's all. So after that, there are n number of blank spaces are available. So only the tape symbol contain x number of zeros. Then we want to check what is the right side value of plus operator. If it is a constant, how many number of zeros should be added? That is the main point. So here 1 is available. That means what? So after the 4th zero, already the tape symbol contain only blank space. but that should be replaced as 0, then only the answer should come. So I only give the logic. The tape symbol contains 0 and blank space. Initially, the tape should start the process with initial state Q0. So if you read 0, you don't do anything, stay in same state. So Q0, 0, right side. At one situation, x number of zeros are read by Q0, then now control head points to blank space with Q0 state. So if it is 1 means you just only change one blank space as 0. So I change one blank space as 0, move to right direction with Q1 state. So if Q1 is occurred, Q1 is the possibility of reading blank space, then you go to final state QF. So this is the logic behind it. So the answer should be in the format of number of zeros. So that is the computation function. For example, I give another example, x equal to x plus 2. Here I am taking x is equal to 4. So what are the tape symbols? Initial blank space, then x number of zeros, and once again blank spaces will be filled in a tape. So each cell contains either zeros or blank space. The control head points to the starting state. So Q0, the tape contains only 0 and blank space in it. If the control head points to initial state, you stay in same state. So 4 zeros are read with the same Q0 state. Then go to Q0, blank space. So you just check the right side plus operator, it contains 2. 2 means we should replace 2 blank spaces as 0. So initial state is available which points to blank space. So I am changing the first blank space as 0 with the new state Q1. And this first blank space is replaced as 0 with the new state Q1. So Q1 second blank space, that is also replaced as 0, move to right direction with final state. So the second blank space is replaced as 0. After that it's not necessary to go further, you can directly go to final state. So this is the logic behind it. But it is not a proper way of handling it. So instead of that, if any variable is given, that means plus y, x plus y. So what is the logic behind it? For example, x equal to 4, y is equal to 2. I want to sum up the answer, that means 6 number of zeros should be presented. So I already told that the tape contains x number of zeros. So I want to put 4 zeros. And y number of zeros means 2 zeros. For differentiating x number of zeros and y number of zeros, the intermediate value should be 1. So the 1 symbol is used for differentiating x number of zeros and y number of zeros. Then the other symbols are blank spaces. So this is the logic. So what should we do means, we don't change the x number of zeros, and only changes means the input tape should contain only 6 zeros, but intermediate 1 is available. So what is the logic behind it means, I want to change this 1 as 0. So totally 7 zeros are available, but my answer should contain 6 zeros. So what should we do? After replacing this 1 as 0, move to right direction and you change the last 0 as blank space. Then the tape contains only 6 number of zeros in it. Okay, so we try to construct a transition table of Turing machine for this addition. So initially the tape contains 0, 1 blank space and the initial state is Q0. So x0 means no change, and 1 means we should change it as 0, go to right direction. If last y0 means replace it as blank space, go to final state. That is the logic. So you just write the logic at right side. So according to it, we should fill up the table. So initial state is Q0, control head points to Q0 0. There is no changes because it is an X0. So then there is no change, it only move to right direction. So up to 1, we come here. If Q0 read 1, that 1 should be replaced as 0 and move to right direction. If you are changing the value, you go to new state. So this is changed with the new state Q1. So it is Q1. If you read Q1 0, just only move to right direction. So for first 0, move to right direction with the same state. For second 0 also, you should move to right direction because we don't know how many y number of zeros are available in an input tape. So until you read blank space only, you can able to find out it. So if Q1 read 0, that means y number of zeros only move to right direction. At one situation, the control head points to blank space with initial state Q1. So if Q1 read blank space, come to left direction with the new state Q2. So if you come to left direction, the second 0, that means it's already available as 0. So the control head points to the last y0 with the state Q2. Then that 0 should be replaced as blank space. Then move to right direction with the final state. It is not necessary to go to new state here. We can directly go to final state with blank space changes. So this is the main logic for implementing addition of two variables by using Turing machine. So the all computation integer functions should contains the integer values as number of zeros. For differentiating x and y number of zeros, the intermediate value will be represented as 1. So I am going to discuss the proper subtraction problem in next class. Thanks for listening.